Hi, Algebra 2 students. These notes are on operations on rational expressions. So by operations, I mean multiplication, division, addition, and subtraction. So we are going to look at all four of those operations today in this video. And I'm going to start with multiplication and division, which is what we went over today in class. And then I'll introduce addition and subtraction, which it will be something a little bit new. But I just want to kind of stress to you that this is all related to fractions because a rational expression is basically one polynomial divided by another in fractional form. Okay, so we're going to start with multiplication. And really, remember when you multiply fractions, you just multiply straight across, right? So my example A, we'll call it, will be 8 times x plus 5 over x plus 7 times x plus 5 multiplied by x plus 7 over 2. Okay, so this is a multiplication of two different rationals, two different fractions, and I'm going to go just multiply straight across. I also want to be looking to see if there's any factors I can cancel on top and bottom, and you could do that before or after you multiply straight across. So I'm basically looking to see like what does the top and bottom of either fraction have in common. So like first of all, I see that there's a 5x in both, or sorry, not 5x, x plus 5. And then I also see like there's an x plus 7 on this one on the top, and there's an x plus 7 on this one on the bottom. I can still cancel those even though they're in different parts of the rational because, well, all I'm going to do is multiply straight across, so eventually they would be top and bottom of the same rational. So now I don't have a lot left. I only have that 8, right? There's nothing else on top, and the 2. And then I could simplify that further by saying, oh, I know what 8 divided by 2 is. It's 4. Okay, it won't always simplify completely to just one number. Sometimes you'll have some factors left over on top and bottom. So that would be multiplication. So now let's do a division one. And just to like give you like a little cue here, we're going to multiply straight across. Look to cancel factors on the top and bottom. Mostly look to cancel the same factors on top and bottom, okay? So that'll just kind of give you a quick description to kind of orient you to multiplication. For division, the idea is we're going to multiply by the reciprocal of the second rational. So this will be example B, and it is 6b plus 48 over b plus 8 divided by 6b minus 24 over 5b. So I'm going to change, remember, dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. So this is equivalent to saying 6b plus 48 over b plus 8. I didn't change the first one, I just brought it over, times, now I'm going to flip the second because that's the reciprocal. Okay, so I see a lot of 6's. I'm thinking that maybe some things will cancel here. It's kind of hard to tell, so the key would be to try to factor top and bottom as much as I can. So I think that there's probably a GCF on the numerator here and a GCF on the denominator here. So 6 goes into 48 8 times, right? So I have 6 on the outside and then b plus 8. I have a b plus 8 on the bottom. That's looking like something I'm going to cancel. Have a 5b, and then here I have a 6 and a b minus 4. So what can cancel? Well, definitely those b plus 8s. I also have a 6 on the top and a 6 on the bottom. Those will cancel. So what am I left with? 5b over b minus 4. And that would be my final answer. Okay, this was the final answer of the first one. Okay. I want to show you one other division one, just because sometimes it looks a little bit different. So this will be example C. So sometimes they'll kind of give you like this crazy double fraction. And don't get scared. Okay, so this is 3m squared minus m divided by 4, all divided by 3m minus 1 over m. Well, we can kind of treat the big division bar, that's the same thing as like this divided by right here, right? So essentially this thing is the same thing as taking the top and multiplying by the reciprocal of the one on the bottom. So like because this thing is getting divided into this. So basically it's saying 3m squared minus m over 4 divided by, like that symbol, 3m minus 1 over m. So I'm going to multiply by the reciprocal. Let me get that. Now I'm looking to see if I can potentially cancel something. I'm looking right here because I see I have an m squared and an m. So I'm going to take out that GCF. And now I see, oh, I have a 3m minus 1 here, 3m minus 1 here. These are both m's, but they're both on the top, so I can't actually cancel them. So all I'm going to do now is multiply straight across. M times m is m squared, and 4 times nothing, or times 1, would just be a 4. So my final answer would be m squared over 4. Okay, so that's multiplication and division. Now I'm going to get into addition and subtraction. And I'm going to do those together because you do the same thing for both. And I'm going to separate it into when we have common denominators and when we don't. So you're going to have to kind of remember back to fractions. So sometimes you have like denominators, and that would make your lives a lot easier if you have like denominators. So this will be example D, okay? So we're going to kind of look at a simple fraction first. If I had like 1/3 plus 5/3, well, they both have the same denominator of 3, so the idea is you add the top and your denominator stays the same. You don't add 3 plus 3 and get 6, you keep it 3 and you add the top. So I get 6 over 3, which is 2, okay? So that's kind of like a baby example, but now let's look at what if you had like some variables thrown in there. So this will be example E. So say we have like 7 over 3y squared plus, say, y over 3y squared. This is a y that kind of looks weird. So now I still have my like denominator, so I just keep that same denominator. I'm going to add the two things on top. Well, 7 plus y, I can't actually combine them, so I just write 7 plus y and leave it be. I cannot cancel one of these y's with this y because this is not y is not a factor of the top. It's being added to 7. So I'm just going to leave my answer as it stands like that. That's all I can do. Okay, so that's like denominators. You're just kind of adding straight across, combining like terms, and keeping your denominator the same. Unlike denominators is a little bit more involved. Just like when you're dealing with real fractions with just numbers. It's more annoying to add when you don't have like denominators. So example F is going to be with just numbers. So I'm going to do 1/7 plus 5/3. And if you recall, you need to get a least common denominator. So that would mean multiplying top and bottom by each one to get a least common denominator, or the least common multiple of the two. So like if I have 7 and 3, they don't have any factors in common. So the easiest thing to do to get the least common denominator, least common multiple, would be to multiply top and bottom here by 3 and top and bottom here by 7. So like worst case scenario, if you're not sure what to multiply by, you can always multiply one by the denominator of the other. right? And you'll end up getting the same thing in both places. So here, the first one is going to become 3 over 21 plus, and then 5 times 7 is 35 over 21. So now I have like denominators, so I'm just going to add straight across, and I get 38 over 21. Now I could try to simplify, but I don't think anything divides both into 38 and into 21. So I'm going to leave it at that. Okay, now let's see how this looks like if we're using actual variables. So this will be example F, example G. We'll start it with like a little baby problem. So my baby problem is 4 over x minus 5 over 3. So I just want to point out, now I'm doing subtraction, but the process works the same no matter what, okay? So the idea here is I have an x as one denominator and a 3 as the other. So I'd like to get the least common denominator, right? So I'm going to kind of write out a step. So find least common denominator. And in this case, that would mean, well, they don't have any common factor, so it's just multiplying one times the other. So this would be 3x, which means to get 3x on this one, the first one, I'd have to multiply top and bottom by 3. And to get this one to be 3x, I'd have to multiply top and bottom by x. So then, we found the LCD, which we know it's 3x. Then we have to multiply top and bottom to get the same denominator in both. So that's what I'm doing here. So I get, on the first one, I get 12 over 3x, and on the second one, I get 5x over 3x. So then I'm going to just subtract on the top and keep the same denominator. So I get 3x and I get 12 minus 5x on top. Now once again, there's no GCF between these two terms, so I can't actually factor anything out to see if nothing is going to cancel out with the 3x on the bottom. I can't cancel these x's out because this is not a factor of the entire numerator. So that's all I could do. That would be my answer. Okay. Let's look at another one that's a little more complex. So that was G, so then this will be example H. Okay, I'm going to just do 2 more examples. I'm sorry if this video is getting a little long, but I think it'll be helpful for class tomorrow if we do more rather than less here. Okay, so here we have x minus 4 and 3x as our 2 denominators. So again, there's nothing that those two have in common. So my LCD is just going to be the multiplication of the two. So like I'm looking to get an LCD that is x minus 4 times 3x. So that means to the first one I have to multiply top and bottom by 3x. And to the second one I multiply top and bottom by x minus 4. So now when I multiply straight across here, I get 27 over 3x times x minus 4. I'm not going to distribute quite yet because I'm thinking maybe something will be able to cancel out, but I'm not sure. But I'm going to leave it in the factored form because it'll be easier to tell. So then here I'm going to get 3 times x minus 4 over 3x times x minus 4. My last step would be to add the top and keep my denominator the same. And I get 27 plus, oh, I'm not sure if anything's going to cancel, but I could distribute that 3 and combine like terms. So I'd get 3x minus 12. And then I could just subtract 27 minus 12 and get 15 minus 3x over 3x and x minus 4. Now I'm actually thinking, oh, maybe something is going to cancel here, right? Maybe because I see like there's a GCF now between these two terms. Oh, I could take out a 3, right? And then I'd have 5 minus just x. and 3x and x minus 4. So now there's one last thing I can do here, which would be, I see that since I was able to take a GCF of 3 out, I would cancel it out with that 3 on the bottom. I couldn't just cancel out this 3x with this 3x. I have to first take out the GCF. Okay, so then I get 5 minus x and x times x minus 4, and I think that's about it. These are never going to be the same. So that would be my answer that I would end up with. Okay. You know what, guys? I'm going to leave the notes right there, and I'll do one more example in class, but this will give us a good foundation to jump off from. So I'll see you guys tomorrow. Bye.